Okay, I would like to discuss the some of the differences between rise over run, and rate of change. Now, in actuality, when we discuss the idea of slope, there is really no difference between the two because they're both essentially are describing the same exact thing. However, I would say the difference lies in application. I like to always remind myself that rise over run is typically more useful to determine the slope when we are referring to graphs, whereas rate of change is more useful when we want to calculate slopes between 2 points. Okay. Now, let's kind of discuss what exactly I'm saying when it comes to application. So if we take like a graph here, like so, and we have some kind of line here, okay, like so, and we have, I don't know, a series of points here, okay. We would want, if we wanted to determine the slope, we would simply want to use the concept of rise over run. So let's say for here, this would be my rise here, okay, and this would be my run, okay. And let me label it as delta y and delta x, where delta is just a symbol that we use to represent like a change, okay, a change. So we're simply saying the change in x and the change in y. That's one way to say it, but there might be some more other formal ways to do it, okay? And we can use this concept to determine the slope of a line from a graph by taking the concept like this. We typically use m for a symbol of slope. We take rise over run, and we simply look at it like so, delta y over delta x, okay? Now, this same concept can be expanded between 2 points. So let me draw another graph here, and we have the following here. I'll put this one here, and I'll put this one here. Let's say this one is 1, 1, and we'll say that this point here is 3, 4, okay? And we want to use the concept of rate of change to calculate the slope. And I'm going to put that equal to m, and we're going to say that delta y over delta x equals our slope, and this can be expanded to include the following: y2 minus y1 over x2 minus x1, okay? Now notice how it's a difference between 2 points here, and this is what we're doing here. We're taking the difference between 2 points. Now, I would argue it doesn't necessarily matter which point you choose as your x1 and y1, or your x2 or y2, as long as you pick one and you stay consistent with it. So, but typically, we might want to choose the one furthest to the right as our x2, y2, and the furthest to the left as our x1, y1. So let's do this here. We'll do a quick calculation of this. So it's pretty simple. I would take the point 3, 4, and I'd probably call it my x2 and y2, and I'll take the point 1, 1, and I'll call that my x1, y1. And we'll just take these values here and we'll substitute it into our equation here. So, let me see here. We're going to do 4 minus 1 over 3 minus 1, and that'll give us the value of 3 over 2. So, conceptually, this number here, 3 over 2, is explaining the same exact thing here, where we have a rise over a run. So essentially the slope is telling us that our line is rising by 3 units and moving horizontally by 2 units. And like I said, they're explaining the difference, and I said conceptually there is really no difference between the two, when the difference would lie with application. Now, rate of change, however, can be expanded to mean a lot of different things, especially when you start dealing with physics and you start dealing with actual changes in motion, for example. But it doesn't necessarily have to be motion. It could be, it could range from, how often your cupcake batter changes or something. You know, as long as there's something changing, you could certainly find the rate of change between 2 points. And it certainly gets more complicated when you start dealing with curves such as these, you know, curves, and you start talking about the rate of change between these two. Okay, notice how if we were to look at here, our rate of change would constantly be changing throughout this curve, okay? And that's another interesting concept, which I can probably come to eventually, but that's, for the purpose of this video, this is way beyond what I was trying to explain. But anyways, I hope this helped some of you as far as trying to understand the difference between the two. And these two techniques can certainly be used to determine the slope of a graph, slope of a line, whether it's on a graph or whether it's between 2 points.